Hi students, this is a video on polynomial long division and synthetic division. Alright, let's start with polynomial long division. It follows all the same rules as long division that you learned in 4th or 5th grade. So there's something kind of fun about it because it really is following those same rules except you're using polynomials. So let's get started. Okay, so the first thing we have to do is set it up as a long division problem. And yes, this looks just like your long division. We're dividing by x minus 2. We need to put the dividend inside in standard form. So let's start with 3x to the third, since that's the highest degree. 3x to the third plus 4x squared. Now there's no x term. It's really important that you put a placeholder in for x, right? And then the constant, plus 10. Okay, so we have to put that placeholder in if there's no term. For example, if you're going down 3 to, we need x to the 1. There's no x to the 1 term, so we put a placeholder in with 0x. Okay, so then what you ask yourself is, we just look at the x. X goes into 3x to the third how many times? Another way of saying this is 3x to the third divided by x is what? And it's 3x squared. So again, 3x squared times x is 3x cubed. Okay? So now what I'm going to do is I'm going to multiply 3x squared, distributing to the x and the negative 2. So 3x squared times x is 3x cubed. That's what I wanted. And then minus 6x squared. Minus 6x squared. Okay? So I'm distributing it to both the x and the negative 2. Now I'm going to put parentheses around this and subtract it. That part's a little bit confusing, but I want to subtract it. So 3x cubed minus 3x cubed is 0. 4x squared minus negative 6x squared. Let me say that again. 4x squared minus negative 6x squared is 10x squared. Okay? All right, so now we're starting all over again. We're saying, let me erase these arrows. We're saying, how many times does x go into, now we're saying, how many times does x go into 10x squared? And it goes in 10x times, positive 10x. Okay? So, again, we're going to distribute 10x times x, 10x times negative 2. And what we get is 10x squared, which is what we want, the same thing, 10x squared minus 20x, minus 20x. Okay? And we're going to, let's also bring down the 0x. That's why we need our placeholder. I'm going to switch colors here. And we're going to subtract, parentheses, parentheses, subtract, because I have to subtract the 10x squared, and I have to subtract the negative 20x. 10x squared minus 10x squared is 0. 0x minus negative 20x. Well, minus a negative 20x is plus 20x. And we'll bring down our plus 10. All right, so now again, let me do some erasing here of my arrows, and let me just do a little erasing of colors here. Let's go with black. We're saying how many times does x go into 20x? And it goes in 20 times, so plus 20. And again, I'm going to distribute the 20 to the x and the negative 2, and I end up with 20x and minus 40. Okay? Line, parentheses, parentheses. I am subtracting 20x minus 20x is 0. You don't have to write the 0, but I'm writing it just to show you. 10 minus negative 40 is 10 plus 40, which is 50. Now, x does not go into 50, so this is our remainder. Okay, we say our remainder is 50. And what that looks like over here is, let's add it on here, is plus, our remainder is 50, and it's 50 x minus 2's. Okay? So, it's our quotient then is 3x squared plus 10x plus 20 plus 50 over x minus 2. Okay, the remainder goes on top of the divisor as a fraction. Okay, so that is polynomial long division. Watch this example over a few times if you need to really understand it. There's examples in your book as well. I chose some different ones than examples in your book. Let's go on to synthetic division. Synthetic division is another way of dividing a polynomial by a binomial. And the way this works here is first we're going to just take the coefficients, that important word, right? 2, 7, and 9. And we are going to write them across 2, 7, and 9. Making sure we put any placeholders in, but it doesn't look like I need any placeholders because I've got x squared, x to the 1, x to the 0. All right, and then I'm basically seeing if negative 2 is a solution. If x minus 2 is a factor, then negative 2 is a solution. So I'm basically seeing if negative 2 is a solution. So the first thing I'm going to do is bring down the 2. Okay? So the very first coefficient I'm just going to bring straight down. Then I'm going to multiply my negative 2 times 2. So let me kind of underline that. My negative 2 times 2 to get negative 4. All right? Then I go ahead and I subtract 7 minus 4 and I get 3. Negative 2 times 3 is negative 6. 9 minus 6 is 3. And 3 is my remainder. Okay? If I get a 0 at the end, then I know it's absolutely divisible, and I'll show you what that looks like. But basically, then what my answer is, right, dividing them here, my quotient is, it would be 2x. So now this is my x term. This is my x term. This is my 3 is my constant, and my remainder is 3. So it looks like 2x plus 3 plus my remainder is 3 over x plus 2. Okay, so now we get to a theorem. You remember theorems from last year in geometry. There is a remainder theorem in algebra. If a polynomial function is divided by x minus a, then the remainder r is p of a. So what does that really mean? Okay, so let's look at this example here. We divided x to the third minus 4x squared plus 5x plus 1 by x minus 3. And you can see what we did. We brought the 1 straight down. 3 times 1 is 3. 4 plus 3 is negative 1. 3 times negative 1 is negative 3, right? 5 minus 3 is 2. 3 times 2 is 6. 1 plus 6 is 7. So my remainder is 7. So it turns out that since it was 3 I was testing out, if I put 3 into this function, I will get 7. Okay? So that means this function, p, right? I put 3 into this. 3 to the third minus 4 times 3 squared plus 5 times 3 plus 1. Let's try it out. We get 27 minus 4 times 9 is 36 plus 15 plus 1. 27 minus 36 is negative 9 plus 15 plus 1. Negative 9 plus 15 is 6 plus 1 equals 7. Okay, so let's try this out. Let's try this out on another problem just to get you a little bit more practice with this idea. Okay, so let's try this out. If I write the coefficients, 5, 9, and 3, I don't need any placeholders, right? And really what I'm looking at is the solution 1/5, right? I'm going to carry the 5 straight down. 1/5 times 5 is 1. 9 and 1 is 10. 1/5 of 10 is 2. 3 and 2 is 5. So my remainder here is 5. Okay, so let's try it out another way. Let's actually put 1/5 into the function, and I should, when I put when I evaluate this for 1/5, I should get 5. I should get this remainder here. Okay, so function p at 1/5 is 5 times 1/5 squared plus 9 times 1/5 plus 3. Okay. Didn't barely get in there. Okay. So p of 1/5 equals 5. Okay, so this is 5 times 1/25, because 1/5 squared is 1/25, plus 9/5 plus 3. Bit of working with fractions here. P of 1/5 equals 1/5 plus 9/5 plus 3. 1/5 and 9/5 is 10/5 plus 3. 10 divided by 5 is 2 plus 3 equals 5. So I do get my remainder. So really what I'm showing you here is that whether I do it with synthetic division, I get a remainder of 5. I can also, if I know that 1/5 is a solution, I can go ahead and evaluate the function at 1/5, and I will get my remainder. All right, so maybe you've got this. If not, let's just run through one more example. Use synthetic substitution to evaluate the polynomial for the indicated solution. Okay, so basically, instead of plugging in -1/2 for x and evaluating, we're going to use synthetic substitution to try this out. So I have my solution of -1/2, and I have my coefficients of 4, 2, I have a 0 for x squared, right? 3 and 5. So I've got a placeholder there for the x squared because there's no x squared term. Okay, so I'm going to just bring down 4. 4 times -1/2 is -2. 2 minus 2 is 0. -1/2 times 0 is 0. Okay. 0 times -1/2 is 0. 3 plus 0 is 3. 3 times -1/2 is -3/2. 5 minus 3/2, or minus 1/2, is 3 1/2. So it turns out, and you guys know that sometimes evaluating these polynomials for a fraction is not easy. This is another way of doing it. So basically, we know now that p of -1/2, right, this function, we're evaluating it at -1/2, equals 3 1/2. Okay, so now you have an easier way of evaluating functions. Hopefully this helps you out with your homework on Wednesday. Please email me if you have questions. I will not see you on Friday, so I won't see you till the following Tuesday. So it's really important, if you're having trouble, take a screenshot, send it to me, ask me questions so that we can move on. We'll go over this a bit when we meet on Tuesday, but then we are also moving on to some new lessons. So let me know if you have questions. Otherwise, I think you're probably ready to get going on the homework.